Jai Shri Gurudev. Good morning to everyone students. Welcome to chemistry class. In the previous class we have studied the chemical properties of carboxylic acids. Under that the cleavage of OH bond, then the substitutes which is effects on the acidic strength of carboxylic acid, and along with we are comparing acidic strength of some various carboxylic acids based on their pKa values or Ka values. Now in this class we are going to study the second chemical property, that is cleavage of ROH bond, that is cleavage of COH bond. The second chemical property is cleavage of COH bond, this one. There are various chemical reactions to study cleavage of COH bond. Now the first chemical property under that is formation of anhydrides. Let's take a formation of anhydrides. To form anhydrides, when carboxylic acid is treated with phosphorus pentoxide or concentrated sulfuric acid, on heating, anhydrides are formed by elimination of water molecule. It means undergo dehydration. That process we called as formation of anhydrides. Now observe here, carboxylic acid or C double bond O, bond H, plus one more carboxylic acid, that is H bond O, C double bond O, bond R. We are taking two carboxylic acids. These two reacts together in presence of vanadium pentoxide, Ve2O5, vanadium pentoxide, or we can also take concentrated sulfuric acid, anyone among these two. These two on heating, condensation takes place, means removal of water or dehydration takes place. Observe here, cleavage of OH bond means the C and O bond is cleaves. These two becomes water. So the resultant one is R, C double bond O, this one. Bond C double bond O, bond R, plus H2O. Two hydrogens and one oxygen. Water is elimination, means dehydration takes place. Results we get anhydride. So this is called anhydride, or C double bond O, C double bond O. This group we called anhydride function group. This is the one of the chemical reaction to know cleavage of COH bond. Okay, now take example. This is what carboxylic acid. These two are carboxylic acids. The reagent is vanadium pentoxide or concentrated sulfuric acid, which is on heating we get anhydride. Now take example. Example say take simple one, acetic acid, C double bond O, bond OH. This is acetic acid, right? Take two equivalents, H bond O bond, C double bond O, CH3. We are taking acetic acid. Now this OH bond is cleaved, means COH bond is cleaved along with this hydrogen. Only in one molecule of carboxylic acids we are observing the cleavage of COH bond. In the second molecule of carboxylic acid, O and H bond is cleaved. Already in the last class we have studied how the OH bond is cleaves. Now these two undergo water molecules, eliminates in presence of the reagent vanadium pentoxide or concentrated sulfuric acid. These two on heating, means these two mixtures on heating, what you get? Observe CH3, C double bond O, this one, and C double bond O, bond CH3 plus H2O. Now what its name? Acetic anhydride. This is acetic acid and we called acetic anhydride. Carboxylic acid we called carboxylic anhydride, or simply we called anhydride. So So its name is acetic anhydride. Okay, so this is the reaction that cleavage of OH. Now take the second one to know cleavage of COH bond is esterification. Now the second method to cleave COH bond is esterification reaction. So very important, the esterification process already you learned in alcohols also. Now the esterification is nothing but when carboxylic acid is treated with alcohols in presence of concentrated sulfuric acid. It means in acidic condition, removal of water takes place and form ester. That process we called as esterification. Okay, and already you know de-esterification reactions in carboxylic acids only. In the last class we learned what is mean by de-esterification. So here the esterification is nothing but carboxylic acids reacts with alcohols in presence of concentrated sulfuric acid. Esters are formed by elimination of water molecule is called as esterification reaction. This is the one of the reaction that knows the cleavage of COH bond. Now observe the chemical reaction. In the esterification process, carboxylic acid C double bond O bond OH, or you can write like that OH, because we are studying cleavage of COH bonds. This is what carboxylic acid, which is reacts with alcohol. Alcohol general representation is RO bond H. So this is what alcohol. This is carboxylic acid. These two reacts together in presence of concentrated sulfuric acid H2SO4. So removal of water takes place, that is OH bond is cleaves H. So what you get? R C double bond O bond R plus H2. So this is called what? Ester. So observe, don't confuse the function group of ester and esters and anhydride. This is ester, R C double bond O and R. In the previous example, you get anhydride, right? That is C double bond O again C double bond O group is repeated, then R. This is called anhydride, this is called ester. Okay, so observe the difference, ester and anhydride. Now we get esters in this case. This process we call as esterification. Now take example. Take acetic acid CH3, C double bond O bond OH, acetic acid, which is reacts with the simple alcohol, that is methanol CH3OH. What will happen? The bond of C and O is cleaves. Elimination of water takes place in presence of water, concentrated sulfuric acid. So what you get? CH3 bond C double bond O, then O and CH3. Okay, plus H2O. Now what is name? Methyl acetate. Methyl acetate. So you get ester, that is methyl acetate. Now we are going to study the mechanism of esterification. Mechanism is nothing but it is a detailed process that know how the COH bond is cleaves in carboxylic acids. Now take the mechanism of esterification. Now we are going to study the mechanism of esterification reactions. So here the mechanism involves the following steps. The first step is protonation of carboxylic acid. Step 1, protonation of carboxylic acid. So observe, in the protonation of carboxylic acid, the carboxylic acid group or C double bond O bond H. So this is the carboxylic acid, right? This carboxylic acid is treating with acid, sulfuric acid. You know, in the chemical reaction, we are treating carboxylic acid with alcohol in presence of concentrated sulfuric acid. Concentrated sulfuric acid is nothing but acidic compound that contain at the domain proton. So, it donate proton, that is we are treating with proton, that is protonation. So, what will happen? Here there is a lone pair electrons and oxygen, carbon of the oxygen that will obstruct this proton. We should show the aromas while writing the mechanism, that is only the important in mechanism. Now R, C, double bond O, bond H. Here electron is deficient, takes place right, so right positive charge. Now remaining is bond OH. This is the step 1. Now the second step, step 2. Step 2 is attack of nucleophile. Nucleophile. Here the nucleophile is alcohol. Nucleophile is alcohol. Now take this one, protonated carboxylic acid, C double bond O, H bond OH plus. Here nucleophile is what? Alcohol. So write alcohol, H bond, O bond, R. This is alcohol, right? We are taking generally the alcohol of an oxygen atom containing lone pair electron again. That will behave as what? Nucleophile. This will attack here. What will happen? This OH is neutralizable. So what you get? R, C bond O, H. This bond is neutralizes this positive charge. Then bond OH, again here O, bond R, then bond hydrogen plus, because electron deficient takes place, right, this will be attached here, HO R, oxygen again deficiency of electron takes place. Now step 3. Step 3 is proton exchange. Proton exchange. Proton exchange takes place. Observe how the proton is exchanges. Take this one, R, C bond OH, bond OH, bond O, R and hydrogen plus. Now here there is lone pair electrons, right, an oxygen atom. Lone pair electrons. So that lone pair electrons take this hydrogen and this oxygen is neutralizes this bond by gaining this bonded electrons. So what you get? Observe. Here the lone pair electrons oxygen abstract ಮಾಡ್ಕೊಂತು ಈ ಬಾಂಡ್ ಅನ್ನೋದು ಆಕ್ಸಿಜನ್ ಅನ್ನು ನ್ಯೂಟ್ರಲೈಸ್ ಮಾಡ್ತು. So right now R, C bond O bond H bond O H bond O and R. Now this hydrogen is get abstract, sorry, oxygen get abstract this hydrogen. Now here bond H got it up. Bond hydrogen, again this oxygen get electron deficient. This is the step 3. Now step 4. Step 4, I will write here better to see step 4. Step 4 is removal of water, that is dehydration. Or you can write removal of water directly. It is easy to understand. That is removal of water. Now take this one. R, C bond O, H2. H and H becomes H2 plus bond OH, bond O and R. Now observe this oxygen again containing lone pair electrons, right, 2 pairs. This electrons pull towards this OH group side, means C and O. Now this will be abstract this bonded electrons between carbon and oxygen. Now observe here, carbon and oxygen bond is cleaves, right, in the 4th step. So what you get? R bond C bond O R bond. This electrons moves towards carbon side, means double bond is formed, bond H plus water H2O. Here H2O is eliminated. That is this step 4. Got it done. Now observe 5th step. Step 5. Step 5 is deprotonation. Deprotonation means what? Protonation means, here observe the first step is protonation, right? Protonation is proton adding. Deprotonation is removing of protons. That is deprotonation. Now take this one. Here again carries positive charge because electron deficient. Oxygen having 3 bonds. Now take that one. R, C double bond O, bond H, bond O, R plus. Now this bond neutralizes the positive charge of an oxygen atom. What you get? R, C double bond O, R plus H plus is eliminated. Okay, H plus is added in the first step and the last step it is eliminated. Means the concentrated sulfuric acid in the chemical reactions behaves as what? Catalyst. Got it? So this is the mechanism of esterification of reaction. Now the third chemical property to cleave COH bonds is reactions with PCl5 means phosphorus pentachloride and PCl3 phosphorus trichloride and also with thionine chloride, that is SOCl2, to form acid chloride. That is the third chemical property, reaction with PCl5 phosphorus pentachloride, PCl3 phosphorus trichloride and thionine chloride SOCl2 form acid chlorides. So in all these 3 cases the acid chlorides are formed. This reaction takes place only in presence of base pyridine. So now observe the first reaction with PCl5. This is the third case in the cleavage of COH bond. Now first one, take PCl5, that is the carboxylic acids. Under that case one, the carboxylic acids is reacts with the PCl5 phosphorus pentachloride in presence of a base pyridine. Observe what will happen. Here this COH bond is cleaved. That is R, C double bond O. After cleaving the COH bond, one of the chlorine get attached. We get the acid chlorides, right? So this is the function group of acid chloride. RC double bond O Cl plus. Now P, this oxygen, and out of 5 chlorine 1 is added. Remaining 4. Out of 4, 3 is combined with phosphorus. That is POCl3, phosphorus oxytrichloride plus. Here there is 1 hydrogen and 1 chlorine. That is becomes HCl. This HCl is gas. Here. Okay. So what we get? Acid chlorides. Okay. This is the reaction with PCl5. General reaction we are writing. Similarly, now write example. Example means take acetic acid CH3C double bond O bond OH plus PCl5 phosphorus pentachloride. This is acetic acid. This is carboxylic acid, C acids we are writing. So now in place of what? Pyridine. PY means what? Pyridine. Just in place of R, what is there? CH3, right? CH3. C double bond and Cl plus POCl3 plus HCl gas. Okay. So what you get? Acid chloride. So its name acetyl chloride. Now similarly take PCl3. The second one is PCl3. That is carboxylic acid RC double bond O bond OH plus PCl3 phosphorus trichloride. This is also reacts in presence of what? Pyridine base. Now to balance the chemical reaction it should need 3 equivalents of carboxylic acid. It means 1 molecule of or 1 mole of phosphorus trichloride is reacts with 3 moles of carboxylic acids. What you get? 3 moles of R C double bond O. In all cases acid chlorides are the main product. So this OH bond is fused. These 3 chlorine atoms are get substituted here. That is bond Cl. Cl into 3, 3Cl. Okay. Now remaining is there is 3 hydrogens and 3 oxygens and 1 phosphorus. So H3, 3 hydrogens, P1 phosphorus and 3 oxygens, that is H3PO3. Phosphoric acid. So acid chloride, carboxylic acid. No need to write the name I got because already here I am written. Now take example. In place of R, take CH3 again in acetic acid. CH3, C double bond O, bond OH. This acetic acid is reacting with phosphorus trichloride, BCl3. In place of what? Pyridine base. Now complete the reaction. I hope you understanding what you get or what you are expected. Definitely acetyl chloride is only the main product. That is 3 equivalent figure. That is CH3, C double bond O, bond Cl, and the byproduct is phosphoric acid, H3PO3. Okay. Now similarly take third one, thionyl chloride. Thionyl chloride. That is reaction with thionyl chloride. Now take general one, R, C double bond O, bond OH. This is what? Carboxylic acid. This carboxylic acid is reacting with thionyl chloride, SOCl2. SOCl2. In presence of what? The base pyridine. So similarly, in this case also what you get, acid chloride is only the main product. Okay. So that we are studying all these 3 cases in a single chemical reaction. Now, R, C double bond O. This OH bond is cleaves. In the place of OH, bond Cl is substituted, means chlorine is substituted. Plus, observe SO and this oxide becomes what? Sulfur dioxide, SO2. This is gas. So that show oxide, or right here gas. Plus, and remaining is 2 out of 2 chlorine, 1 chlorine is substituted. The second chlorine and hydrogen becomes again HCl. Gas. This is also gas. You can write here upside Hagamarkar gas, your wish. Here gas is state. This is an general chemical reaction. Now similarly take the chemical reaction example, acetic acid or any one, your wish. Take simple one. That is OH, acetic acid, which is reaction with what? Thionyl chloride, SOCl2. In presence of pyridine base. P1. What will happen? You expected acetyl chloride only because you are taking acetic acid. Right? So write the acetyl chloride CH3, C double bond O, bond Ca plus the byproducts are sulfur dioxide gas and HCl. So students, this is the very important chemical reaction. Among these 3, definitely they will ask for 2 marks any one of the reagent given with carboxylic acid and to write the products or to ask to complete the chemical reaction. So remember, in the case of PCl5 or PCl3 or thionyl chloride, the product is acetyl chloride only. So here observe the importance of thionyl chloride is in the case of thionyl chloride, when reacts with carboxylic acids, you get acetyl chloride, means acid chlorides, and the byproduct is sulfur dioxide and hydrogen chloride gases. These gases easily expels out and we get pure acid chloride. So that this method is very sufficient and best one to prepare acid chlorides by comparing these two. That is reaction with PCl5 and PCl3. ಇವೆರಡಕ್ಕೂ ಕಂಪೇರ್ ಮಾಡಿಕೊಂಡ್ರೆ ಥಾಯನೈಲ್ ಕ್ಲೋರೈಡ್ ಮೆಥಡ್ ತುಂಬಾ ಸಫಿಶಿಯೆಂಟ್ ಆಗಿ ಈಸಿಯಾಗಿ ಬೆನಿಫಿಟ್ ಆಗಿರುತ್ತೆ. ಯಾಕೆಂದ್ರೆ ಬೈ ಪ್ರಾಡಕ್ಟ್ಸ್ ಅನ್ನೋದು ಸಲ್ಫರ್ ಡೈಆಕ್ಸೈಡ್ ಮತ್ತೆ ಹೈಡ್ರೋಜನ್ ಕ್ಲೋರೈಡ್ ಗ್ಯಾಸ್ ಬರುತ್ತೆ. ಈ ಎರಡು ಗ್ಯಾಸಸ್ ಈಸಿಯಾಗಿ ಎಕ್ಸ್ಪೆಲ್ ಆಗುತ್ತೆ. ಎಕ್ಸ್ಪೆಲ್ ಆಗೋದ್ರಿಂದ ಆಸಿಡ್ ಕ್ಲೋರೈಡ್ ಅನ್ನೋದು ಪ್ಯೂರ್ ಆಗಿ ಸಿಗುತ್ತೆ ನಮಗೆ. ಆದ್ರೆ ಇಲ್ಲಾಂದ್ರೆ ಫಾಸ್ಫರಿಕ್ ಆಸಿಡ್ ಬರುತ್ತೆ ಬೈ ಪ್ರಾಡಕ್ಟ್. ಈ ಫಾಸ್ಫರಿಕ್ ಆಸಿಡ್ ಅನ್ನೋದು ಫುಲ್ಲಿ ಅಸಿಡಿಕ್ ಆಗಿರುತ್ತೆ. 3 ಪ್ರೋಟಾನ್ಸ್ ಇದೆ ಮತ್ತೆ ಥಿಕ್ ಸೊಲ್ಯೂಷನ್ ಆಗಿರುತ್ತೆ. ಇದು ಅಷ್ಟು ಬೇಗ ಎವಾಪರೇಟ್ ಆಗೋದಿಲ್ಲ, ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸೊ ಆಸಿಡ್ ಕ್ಲೋರೈಡ್ಸ್ ಅನ್ನು ಈಸಿಯಾಗಿ ನಾವು ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳೋದಕ್ಕೆ ಡಿಫಿಕಲ್ಟ್ ಆಗುತ್ತೆ. ಸಿಮಿಲರ್ಲಿ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಒನ್ ಈಸ್ ಫಾಸ್ಫರಸ್ ಆಕ್ಸಿ ಕ್ಲೋರೈಡ್ ಇದೆ, ಇನ್ನೊಂದು ಹೈಡ್ರೋಜನ್ ಕ್ಲೋರೈಡ್ ಇದೆ. ಫಾಸ್ಫರಸ್ ಆಕ್ಸಿ ಕ್ಲೋರೈಡ್ ಅನ್ನೋದು ಅನ್ಸ್ಟೇಬಲ್ ಆಗಿರುತ್ತೆ ಆಸಿಡ್ ಕ್ಲೋರೈಡ್ಸ್ ಇಂದ ನಾವು ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಆಗೋದಿಲ್ಲ. ಗ್ಯಾಸ್ ಹೈಡ್ರೋಜನ್ ಕ್ಲೋರೈಡ್ ಅನ್ನೋದು ಗ್ಯಾಸ್ ಆಗಿ ಎಕ್ಸ್ಪೆಲ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಓಕೆ, ಇದರಲ್ಲಿ ಹೇಡ್ ಬೈ ಪ್ರಾಡಕ್ಟ್ಸ್ ಇರುತ್ತೆ, ಇದರಲ್ಲಿ ಒನ್ ಬೈ ಪ್ರಾಡಕ್ಟ್. ಇದರಲ್ಲಿ ಹೇಡ್ ಬೈ ಪ್ರಾಡಕ್ಟ್ಸ್ ಇದ್ರೇನು ಎರಡು ಗ್ಯಾಸ್ ಆಗಿರೋದ್ರಿಂದ ದಿಸ್ ಇಸ್ ದಿ ಕನ್ವೀನಿಯಂಟ್ ಅಂಡ್ ಬೆಸ್ಟ್ ಮೆಥಡ್. ಓಕೆ, ದಿಸ್ ಇಸ್ ದಿ ನೋಟ್ ಇನ್ ದಿ ಕೆಮಿಕಲ್ ಬಯಾಲಜಿ.